This is a June 2025 question, which is on the improvements of rudder efficiency that can be considered, which can contribute to the propulsion efficiency. So mostly it has to do with the effect of rudder thrust fins, the asymmetric rudders, rudder bulbs, and Vane wheels. So here's a detailed discussion on the rudder efficiency improvement devices and techniques currently used in maritime propulsion, contributing significantly towards the fuel saving, the reduced emissions, and enhanced maneuverability. First of all, rudder thrust fins. So the description is that the rudder thrust fins are small wings-like appendages, basically an appendages fitted on the rudder surface, usually near the leading edge. So at the leading edge of the rudder surface there is appendages that has a small working wings. These are called as a rudder thrust fins. Now, what is the benefit and the functions of these rudder thrust fins? These fins redirect the rotational flow generated by the propeller into the most useful axial thrust. So you need axial thrust. So they are placed in certain angle so that the rotational flow results into axial thrust. By recovering the energy lost in the propeller's rotational wake, the fins help generate forward thrust. This overall has an increase in efficiency from 2 to 4%. It also reduces rudder torque, leading to better steering response and less wear. Application widely used in container vessels, bulk carriers, especially in retrofitting applications for energy saving devices. So this is a retrofit. Part of the retrofit can be carried out at the dry dock. So these small uh, appendages on the leading edge of the rudder creates 2 to 4% improve in the overall efficiency of the propeller. Also, the rudder torque is getting reduced, which leads to better steering response, and also the additional axial thrust, which is uh, which is got in the process. Now, the second part is about the asymmetric rudders. Asymmetric rudders have a non-symmetrical cross section with the deliberate angle of attack relative to the propeller wash, even in the midship position. Functions and benefits designed to match the rotational propeller's slipstream. They align better with the flow direction, reduce resistance, and enhance lift force at zero rudder angle, hence improving the efficiency overall. And this can result into fuel efficiency by more than 4%, reduce steering effort, and enhance straight line tracking. The application is used in high efficiency vessels, particularly those with fixed pitch propeller and high speed operation like tankers and large container vessels. Asymmetric, basically the cross section of the rudder is asymmetric in nature, and overall the fuel efficiency is improved by 4%. And also the rudder bulbs. A rudder bulb is a torpedo-shaped bulb attached to the rudder stock, placed directly behind the hub of the propeller. Functions and benefits: recovers energy from the hub vortex by streamlining flow around the propeller boss cap, reduces hub vortex and associated energy losses, increases the pressure behind the propeller, enhancing the thrust, can yield 1 to 2% improvement in the propeller propulsion efficiency. Application often combined with asymmetric rudders or thrust fins, especially beneficial to full form hull shape like tankers and bulk carriers. So Grim Vane wheels. A Grim Vane wheel is a propeller-like device with curved vanes located ahead of the immediately downstream of the main propeller. So at the downstream of the main propeller, you have these Grim Vane wheels. Functions and benefits: installed in the propeller wake to counteract the rotational swirl generated by the propeller. The wheel rotates freely and recovers energy from the rotational flow, converting it into additional thrust. Can improve propeller efficiency by 4 to 6%. Also enhances flow uniformity into the rudder, improving rudder efficiency. Application: more complex to install, often seen in new build vessels with strong focus on hydrodynamic operations. So here is a summary. The rudder thrust fins, you get a 2 to 4% increase in efficiency with asymmetric rudders 3 to 4%, rudder bulb 1 to 2%, and Grimvane wheels 4 to 6%. So primary function of the rudder thrust fins convert rotational flow into axial thrust. Asymmetric rudders aligns with the propeller wake to reduce drag. Rudder bulbs recovers hub vortex energy. Grill main wheels recovers rotational energy via wheel rotation. These devices become part of the energy saving devices, which is important in the commercial shipping.